Hello, and welcome back to the course Network Analysis with Python. I am your instructor, Somyajit Chakraborty. Today, we are going to look at some of the definitions of network and its terminologies. So, how can we define a network? Well, network can be defined by using the graph theory, mathematical concept of graph theory. Uh, in the first video, we already described a network as a collection of items which have interconnections among them. Now, according to graph theory, these items, which are our major topic, means which we will concentrate, are called as the nodes or vertices, and the links or the relationship between these nodes can be represented by what we know as edges. So here we have implemented Python to create such networks. So we have used, like we said in the previous video, that we will use network X to implement or build such networks. So here we have used the graph function to create a network with edges from A to B and B to C. So there are two connections between these nodes A and B, and there is another connection between the nodes B and C. Now, A and C might not be connected, so they are basically, this represent basically a line graph. So, examples of such networks. Now, some of the examples of networks, like we have already discussed in the previous video, are social networks. Now, these social networks generally tend to have a symmetric relationship between the nodes. Now, here in this picture, it is basically a friendship network. So the nodes are people and the edges are basically their friendship status or marital ties, family ties. Now, why they are called a symmetric relationship? Because these nodes share a mutual interest among themselves, so they have a symmetric relationship. Now, another kind of network are those networks which have asymmetric relationship. Now, here is an example of a food chain in a lake. So here the birds are the nodes, even the fish, they are also the nodes. So these nodes do not, we users do not choose, they choose themselves. It is by defined by the law of nature that which nodes will be connected with other nodes. So here it is not up to the user to set up the edges, it's by default. So this kind of relationship are asymmetric relationship, meaning these edges are not mutual. These nodes are related, but they are not mutually related. Okay, so networks can be broadly classified into two major network kinds: undirected networks and directed networks. So undirected networks are basically networks which have no direction, edge direction. And the directed networks, as the name suggests, have edge directions. Now we will use the function digraph to create such networks. Okay. Let us come to the topic of weighted networks. Now there are some networks which have relationship. Now we want to grade what is the level or what is the value of those relationship between these nodes. For example, here is a network for authors who have collaborated with other authors. Now the numbers 6, 13, 21, these numbers are basically edge weights. They represent how many times these authors have collaborated with one another. So these kind of networks are very important because edge weight gives us a very broad view of what the network is about, or what the network wants to convey. So this is a very important concept, these weighted networks. So we don't need any other function, just we have to add an attribute of called weight along with the add edge function, so in order to create weighted networks. Another kind of weighted networks, they are not basically weighted networks, they are basically the sign networks. So these are special attributes. For example, in a network, not every node has a positive relationship. Some of them have negative relationship. For example, in a social network, or in a virtualization of a social platform, where you meet people. So a person A and B can be friends, but a person B and C might not be friends. So here it is a network of basically friends as well as enemies. So this is a very common example is slash dot. So where we can declare friends and foes. So they have a negative impact on the network who have enemies, and they have a positive impact on the network who have friends. So we don't need any other functions. We just use an attribute sign to represent whether they have a positive relationship or a negative relationship. So such networks are basically called as the signed networks. Previous network A and B, they are all friends, family, and co-worker. A and B could be family as well as a co-worker or a neighbor. So these kind of networks, so such complicated network relationship can be represented via means of multigraphs. So visualization. So I have written a code in Colab. So this is a code segment showing how to create and visualize a graph. Now we know how to create a graph, but how do we visualize it? We use the visualization Python library matplotlib. So first let us create the graph, then we use the nx.draw function to um, chart out the graph, and then leave all the rest to matplotlib to create and plot the graph. So here we have created a multi-graph. Now the problem is, for multi-graphs, they they have multiple edges. There can be multiple edges between the same nodes. So A and B actually has two nodes, as you can see from the code. But due to some visualization problems, which generally occur in case of drawing such graph, is basically it is 3D in nature. So we need 3D visualizations. I tried to make the code as simple as possible. So here in this code, A and B is the edge between A and B is a bit darker, because actually there is two edges. So that is why, and A and F has one single edge. So that is why this edge weight, or the edge length color, is basically faded, because it has one edge. Same with the case with F and G. The nodes F and G, they have two edges, so they are a bit darker. Okay, so this is the visualization of a network. We will use this visualization. We will not really concentrate on the visualization very much, but we will concentrate on creating networks. uh, uh, Draw function, this nx.draw function has some special features. So these special features, we will explore such special features in the upcoming lectures. Okay, so let us summarize what we have studied so far. So there can be several types of graphs. First is the undirected graph, which is basically a simple graph. Another is a directed graph, which we call as the digraphs. So die networks, or the directed networks. So we use the digraph function to create such networks. Okay, then we use signed attributes to create signed networks, and weight attributes to create weighted networks. And for multigraphs, we use multigraph function to create multigraphs and other parameters concerning networks which have multiple relationships. Okay, thank you.